Okay. You also are able to actually record these classes if you want to.
Okay.
If you feel like that's going to be helpful, look, it's not always helpful to have too many different things to look at because you need to spend some time in your textbook as well to do the examples. Okay.
Yeah.
So what we're going to do today, we're going to look at an overview um, of what the atom looks like. So protons, neutrons, and electrons, and how we actually draw them, uh, find out where they are, and what happens if a certain atom or element loses electron or gains electrons. And we're going to look at that in uh, a broad spectrum view or a wide angle view of the atom. Okay. Do you have a periodic table, perhaps?
I don't have one, but I know that there's one in my book.
Yeah, you need to have one today ready. I don't know if you're able to print or something.
I think I might be able to.
Um, okay. What I'm going to do, I'm just going to quickly drop one in your inbox because it's important that you actually have a physical uh, periodic table next to you because you're going to do some writing on it. And I'm not sure if you want to actually write on uh, on the one in your textbook.
Yeah. I can you maybe send it to Annie and then she can print it for me?
Okay. Is she there now?
Yeah. I'll just ask her if she can.
Okay. I don't know. I'm not sure if she's going to be able to do it from her phone. Okay. But in the meantime, have the one in front of you, one in your textbook in front of you. It will look like that. Can you see it?
Um,
It should be
yeah.
right at the back in the textbook, actually.
Okay. Okay, yeah, I have it.
Okay, but we are predominantly going to work with this section. We're going to
Okay.
ignore these elements. We never use them in school. Some of them are radioactive. We don't even have the molecular mass of some of them and blah, blah. So they're not important at all. So if I, oh, actually, we're going to use less. So I'm just going to cut the periodic table, probably down to potassium or something, because we don't even use rubidium. We use mostly those elements.
Yeah.
So I've cut it there. Oh, I cut it at rubidium. Okay. So if we look at this, um, your periodic table is going to have normal numerical group numbers. So all the groups are the ones that goes vertically down. This is called a group. And we use the Roman numericals. So this is called group one and group two. And then we skip these groups because they're called transitional metals. And then this is group three again, and then four and five and six and seven and eight. But you are familiar with those Roman numericals.
Yeah, I am.
Okay, so we call if I refer to group one, this one, group two is this one, and then group seven is that one, group eight, and then six, and then five, and then four and three. We don't use these transition metals, so in school, so we don't refer to them in group numbers. So these are called groups, and then everything that goes horizontal is called a period.
Okay.
So if I look at, for instance, magnesium here, magnesium will be in group two, but in period three. You see that?
Yeah.
Okay. So what is important is that the group number. Now, everything we're doing now is really important because you're going to fit all your chemistry that we can do this year um into this like overview. So if I look at the element magnesium, it is in group two and in period number three. Now, group two tells me the number of valence electrons. So this is the number of electrons in the outer shell Okay, maybe you don't know what that means yet. But just remember that. So group 2 gives me the number of electrons in the outer shell. So electrons are like planets moving around the sun. So if this is the sun, then there's orbits around the sun. This we all know. There's the first orbit, there's the second orbit, and then there's the third orbit. So we have the sun there, and then we have certain planets. Maybe you would know which planet moves in the third orbit around the sun. Earth.
I'm
Isn't it Earth?
yeah, it
We
is.
are we are called the third rock from the sun.
Yeah.
Okay. So, okay, the group number will tell you how many planets are in that orbit. So in this case, in group 2, now group 2 refers to this group 2 refers to the number of electrons. So in this case, then there will be 2. Every element in group 2, there will be 2 electrons in the outer shell. The outer shell is just the area furthest away from the sun, from the nucleus. Okay, so, and then the period will tell you how many, maybe I must write that, how many areas around the nucleus. So if it's in period 3, then there's 3 areas where electrons can move around the nucleus. So with magnesium, we know the following. I'm going to draw you the magnesium atom, what it looks like. There's a nucleus right at the center. Can you remember what the nucleus consists of? Protons and neutrons.
Yeah.
Now, magnesium is in period 3. So there's 3 areas around the nucleus where electrons can move. And the fact that it's in group 2 tells me that in the outer shell, the third one, we have 2 electrons. So that's an electron and that's an electron. Now, this is very important with regards to bonding because an element can either lose electrons or gain electrons. Okay. Right. So we're going to just practice this. This is like step 1. And then we're going to come back and do step 2 and 3. And then you're going to fill in the whole thing. So this, in the nucleus, there's protons and neutrons. And then around the nucleus, we have electrons. And they move around the nucleus in various forms, some circular and some in the form of 8. So some of the electrons just move around in circular form or spin around the nucleus. Some of them is like on a track in a figure 8. Some of the electrons move like this in a figure 8, and some of them just move around. Okay, right. The second thing that you need to know is, what does this number represent? I'm just going to copy one. We're going to be still busy with magnesium as our example. And I'm going to look at these numbers. What does that top number there represent?
I'm trying to remember. Let me quickly.
Okay, well, look at your periodic table. It says atomic number.
Oh, atomic number.
Okay.
Yeah.
What does that actually mean?
The number of atoms.
The number of protons.
Oh, protons.
Protons. The proton is what distinguishes each element from another. So there will be only one element in the whole of the universe that has 12 protons, and that is called magnesium. So you look at your periodic table, just below magnesium, there is calcium. Now that's the only element that has 20 protons. Okay.
Yeah.
If you want to make more money than the lotto, if you want to make more money, then you must find a way to change those proton values. Because then we can change magnesium into gold or helium into silver. If we can change helium into silver, then half of our atmosphere is going to be silver. Then we can start selling it. No.
Yeah.
Okay, but that is not possible to do. Okay, so the atomic number stays put the same for each one. And then we have a 24 at the bottom. Do you know what that value is?
Approximate relative atomic mass.
Yeah, atomic mass, or it's also called relative atomic mass. And I think at this stage you will either use m as a symbol for that, but that's going to change later, so just check that. Some books just use me as a symbol or m as a symbol, like that.
Yeah.
Okay, that is the number of protons plus the number of neutrons. What is a neutron? It's a little part, a small alpha particle that doesn't have any charge.
Yeah.
What charge does a proton have?
A positive.
An electron?
A negative.
A negative. Okay. Right. Okay, so this is good. So we're going to do an example of this. I'm just going to take magnesium away. So we're going to look at chlorine. Okay, now we have a problem. That's a bad example. And you can't do that yet. So I'm going to do fluorine. Would you actually know these elements' names? If I just give you F, would you know it's fluorine or not yet?
Well, I would think it might be fluorine.
All right. Okay, let's go. Look at that example and tell me how many protons do we have in that atom?
9.
9. Very good. I just want to move this away. This is now irritating. Okay, so we have 9 protons. 9.
Yeah.
How many neutrons do we have?
10.
10. Very good. And if the atom doesn't have any charge, how many electrons do you reckon we have? If there's no charge, then the protons and the electrons must equal one another. Because if I have one proton too much, then it will have a positive charge. And if I have 2 electrons too much, then, or 2 more, then it will be a -2 charge. So you agree that the electrons is also 9?
Yeah.
What is the mass number or the relative atomic
19.
mass? 19. Okay. And the atomic number?
9.
9. Very good. Okay. Now, what we're going to do, I am going to look at fluorine and ask you, I want to know in what group is this and in what period is this element?
In group 7.
Very good. And what period?
2.
2. Okay. So now I know that the atom looks like this. There's the nucleus. It consists of neutrons and protons. And then I have an area that electrons will move. 1, 2 of them. Why? Because it's in period 2, it will have 2 areas where electrons will be able to move. It's called orbitals. Okay. Yeah. So in the first, okay, we have very important. In the first area around the nucleus, there can only be 2 electrons, always, for all the elements. And then every area after that can have 8.
Okay.
Except for the metals that's called transition metals. But guess what? We don't do them. Okay. That's why we don't use them at the moment. So In the second orbital or area, it's called energy level. Your book will refer to energy level. In the second energy level, there's a possibility of having 8 electrons. But would you agree with me? I can actually only put 7 there because there's only 9 electrons to put in.
Yeah.
So I'm going to group them 2, 4, 6, 7.
Yeah.
That is called a Bohr diagram. A Bohr diagram.
I remember doing that. Yeah.
Okay, these are called Bohr diagrams. So this is a Bohr diagram. And then there's another diagram that you have to learn. So we're going to do all of this in one go. That's a Bohr diagram. And the next
And then isn't the other
Aufbau,
diagram? Yeah, that. Yeah.
Aufbau diagram. So what Aufbau is just a diagram that shows you where the electrons are. So we have n equals 1. That refers to the first area where electrons can move, or the first orbital, or energy level. And in the first energy level, you have to learn there's only one orbital, one area where electrons can move. It's called 1s. The
Yeah.
1 stands for number 1 or area number 1, and S is a spheric orbital. Now, in that orbital, we have 2 electrons, 1, 2, and you have to draw them so that they spin opposite ways. So the one is an arrow, half arrow up, and the other one's half arrow down. You
Yeah.
can also draw this in a block. You don't have to have a circle there. You can also use a block, but I like a
Yeah.
circle. And then in the next level, energy level 2, there's a spheric orbital. It's called number 2s. And then there are 3p orbitals
Yeah. And then
called
it would
2p.
be one up, one
One up,
down, one
one
up,
down.
one
Okay,
down.
this represents maybe these 2 electrons. And then
Yeah.
and then you have to fill it up like this: 1, 2, 3, 4, and another one is 5. So there's 9 electrons in total. 2, 4, 6, 8, 9.
Yeah.
And that's called Aufbau diagram. That is,
I I
oh,
I
you've
did that over
oh, you've
there.
completed it already. Okay,
Yeah.
awesome. Awesome. Then we're gonna run through this work really quickly. So what I'm gonna do, I am gonna choose another example. We are gonna use sodium. I'm just gonna copy it here. Sodium is a very important element. We use that a lot.
Yeah.
The first thing you're going to do, you're going to answer this question or these questions: how many protons, neutrons, electrons, molar mass or mass number or an atomic number. Then I want you to draw a Bohr diagram. And then I want you to draw an Aufbau diagram.
Okay.
And then we're going to move over to ions.
So for the Bohr diagram, it's
Well,
a
you first
circle.
need to answer the following group number and period,
Oh yeah.
because that will help
The,
you a lot.
the
That'll
group
show
number's
you how many you
one,
must draw.
period 3.
Period 3, group 1.
Yeah.
Okay, see what you can do.
So since it's 3, there would be 3 circles.
Yeah.
And then only 2 uh can go
In the
in
first
the
one. Okay, you want to
middle.
do it together.
Yeah.
Okay, so just make a little dot there to represent the nucleus. And then I need 3 areas for Bohr. Just going to make
Yeah.
the first one nice and small so I have more space. Duplicate, make the next one bigger. Duplicate, make the next one bigger. Because there's my Bohr diagram.
Yeah.
So the first one, I can only have 2 electrons. 1, 2. Okay, how many electrons, by the way? We haven't filled
Um,
in these values. Let's do this first. How many protons, neutrons, electrons, etc.?
so 11 protons and 12 neutrons.
Very good. Electrons.
12 electrons or 11 electrons.
Good. Mass number.
23
Atomic.
and 11.
Okay, very good. Okay, now, so we have 2 electrons in the first energy field. Or
Yeah.
how many in your second?
4, 5.
No. It's only in the first one, that's 2, and all the others can take up to 8.
Okay, so then
2, 4, 6, 8. So now we've spent 11 of the 10 of the 11 electrons. Okay.
and then you can just add the other two on the.
Okay. So what does group one mean again? Group one means that there's only one electron in the outer energy field. And period 3 means there's 3 areas where where electrons can move, or energy areas of energy. Okay. Okay, and then the F-bar diagram will have
It
1
would have
and 2
yeah.
and N3.
Yeah.
Okay, you're going to draw it.
So it would be 1, 2, 3, 4, uh,
So I'm just copying and pasting.
yeah.
So it's going to look like this. Remember, all the energy, all the energy levels will have S's and P's. It's only energy level 1 that's got a 1S. Now this one is 2S and 2P, 3S and 3P.
So it would be on 1S it would be up down, on 2S it would be up down, on 2P it would be up down up down up down,
Okay.
and on 3S it would be up.
Very good. Very good. Very good. Very good. Okay. Okay, so what I'm going to do, I'm just going to duplicate this page quickly. And now we're going to work with not sodium, but sodium's ion. Now, look at this before we look at this Bohr diagram.
Yeah.
So sodium's got 1 electron in the outer shell. Okay.
Okay.
It can either fill it up with adding another 7. Remember, in all of nature, and especially in chemistry, everything wants to move to a state of lower energy.
Yeah.
Because it's more stable. So sodium is kind of desperate either to lose that electron or to gain 7. It doesn't want a half-filled orbital at all.
Yeah.
So sodium is not going to gain 7 electrons. It's much easier to just lose an electron.
Yeah.
Okay, then sodium becomes sodium ion. Now, can you explain to me why it's now suddenly +1?
Because there's an equal number of protons and neutrons.
Nope.
Oh.
If it has the number of neutrons doesn't affect the charge because a neutron doesn't have a charge. We've just lost an electron. So in other words, here we'll have 1 electron less.
Yeah.
So that becomes 10 electrons. Okay. So now we have 1 proton more than the electrons. And that's why we have a positive charge on the sodium.
Okay.
So the Bohr diagram will now lose this electron. Yeah. See.
Yeah.
So this is the Bohr diagram of sodium ion, or this sodium ion. And the F-bar diagram will lose the electron in that 3s orbital. And this is the Aufbau diagram of sodium 1 plus.
Yeah.
Okay, so you need to write that down as well, because you need to be able to draw. Look, drawing Bohr diagrams is not that important. The Aufbau diagram is important, and filling in the number of neutrons and protons and electrons are really important.
Okay. So okay.
Got it.
Yeah.
Okay, we're going to do a new one. We are taking out, let's do oxygen. Oxygen is another important one. So there's oxygen. Okay, first thing you're going to do is fill in all those questions there. How many protons, neutrons, electrons, etc.
So 8 protons, 8 electrons,
8
8
neutrons,
neutrons, and then 16 mass number and
atomic.
8
Okay.
atomic number.
Okay, so you get oxygen. I'm just going to show you something interesting. You get oxygen is always 8 protons, but you can get various, it's called isotopes of oxygen. So oxygen can have the following isotopes. Look at that. Oxygen with mass number of 16, one with 15, and one with 17. All the only difference here is the number of neutrons in the nucleus. Can you see? The one is 8, the other one is 7, the other one is 9.
Yeah.
So the neutrons can change or differ. These are called isotopes.
Okay.
But the number 8 on the oxygen can never change. The minute we change that, it's not oxygen anymore. Okay.
Yeah.
All right. Okay. So now what I want is I want a Bohr diagram, and I want a Aufbau diagram.
So it would be,
Let's first get the group and the period right.
yeah. So the group is 6
Yeah,
and the period is 2.
good. So in the Bohr diagram, it's nice and easy now, because I know I only have to draw 2 areas or energy fields or areas where the electrons can move. And in the Aufbau diagram, I have energy level number 1 and number 2.
Yeah.
And in 1, there's a 1s orbital. And in 2, there is a 2s orbital and 3 other, oops, 3 other s orbitals. It's called, p orbitals, 2p orbitals. And then I fill in.
So it would be one. It would be 2 in the first
Energy
thing.
level,
Yeah. And then there would be 6 in the outer one.
very good. Okay, now, diagram for Aufbau.
So it would be up, down, up, down, up, up.
That's it. No, two more, two more.
Yeah. Up,
Up, down.
up, down. Yeah.
Okay. Okay, now
Okay.
look at that. I'm just going to duplicate this because we're going to be working with the. Now look at this. We are going to change oxygen to oxygen, the ion.
Okay.
Okay, now look at the Bohr diagram or the Aufbau diagram. It doesn't matter, or group number. I'll go back to this now in a second. Now, if you look at that Bohr diagram, I've got 6 electrons in the outer shell.
Yeah.
Now, oxygen can either lose the 6 or gain 2 more electrons. And
Yeah.
it will be easier to gain 2 more electrons.
Yeah.
So oxygen becomes 2 minus because it gained 2 electrons. Now the 8 electrons becomes 10 now because it gained 2
Okay.
electrons. And then I add 2 electrons in the Aufbau diagram as well. So this is the Aufbau diagram of oxygen ion.
Okay.
Okay, make a note of that. Do you have any questions on stuff you're doing at the moment?
Um, Not really. I mean, we currently doing the stuff I'm doing at the moment, so
Do you
it's
also have other classes? Are you attending uh, the Impact School or something as well?
um I'm watching the videos. I'm not attending any of the classes though.
And they've already done this work.
Well, we are busy doing it since it's almost the end of term. We basically done it. We also doing like metallic bonding, ion
Uh,
bonding.
we'll get there.
Yeah. But I think I still don't really understand it, so it's gonna be easy if you just go through it with me.
Yeah, we'll get there. We're just building up. Okay, so now do you understand what we've done now?
Yeah.
Okay, so now if I go back to this periodic table, so all the elements in group 1 will always have an ion that's +1. All the elements in group 2 will always have an ion that's labeled 2 plus, or you can use +2. Doesn't matter. So the charge is +2 or 2 plus. Okay. Then in group 3, it will be 3 plus. So I use the number in front of the sign. Then in group 8, right at the bottom, back, there will be no charge. These are non-reacting gases. They are inert. And they're called, what they called again in English? Can't remember that word now. I'll get to it in a second. They have a specific word. They are inert. They don't. The reason is they all their energy levels are always full.
Okay.
Noble gases. Noble gases. They're always full. So they don't want any electrons extra. They don't want to give electrons away either. So they're going to have no charge. Then in group 7, it's always a -1 charge or a 1 minus charge. Okay. And then in group 6, it's always 2 minus. So 1 minus, we just use a negative there. Okay.
Yeah.
And then in group 5, very important, it can be 3 minus or 5 plus. And then in group 4, it can be 4 minus or 4 plus. So group 5 and 4 is problematic. Okay. It all depends if they are bonding with metals or non-metals. So this is the important thing I want you to write on your periodic table.
Okay.
Because the group number also in a way represents not just the amount of electrons in the outer shell, but also the charge that it will have, because it will always lose those electrons or gain electrons.
Yeah. Okay. I've written it down.
So this becomes really important because if I tell you, okay, fine, we have beryllium here. I'm just going to highlight it. There it is, beryllium. I want you to know what would the iron look like? Then you don't have time to go and draw an off-power diagram or a Bohr diagram. You just simply don't have the time to do that.
Yeah.
The only thing that you have to do is go to the group number, see it's group 2, and then you know that the ion will look like this. It's beryllium 2 plus. Okay.
Okay, I see.
That means actually that it lost 2 electrons. That's
Yeah.
the way it became +2 or 2 plus. So whatever beryllium is bonding to, so whatever, so let's say the atom bonding to beryllium will gain 2 electrons. This is how one of the ways chemical bonding occurs. If someone gives electrons to another element or a group of elements, and the charge is changed, the one losing the electrons becomes a positive, and the one gaining the electrons becomes a negative, and the positive and negative attract one another, and so they bond. So this is
Yeah.
called ionic bonding. You've heard of that.
Yeah.
Okay, so this is called ionic bonding, where ions bond. And the way ions are formed is either by gaining or losing electrons. I think you've got this kind of under control. Okay. So you can draw Aufbau diagrams, you can draw Bohr diagrams. You know where to find an element, and you know which group number they are and period. So you can determine the charge as it becomes an ion. Now, there's a reason we need to be able to do this. You ready?
Yeah.
So I'm just going to copy this periodic table because we need to actually bond stuff. This is what chemistry is all about, throwing stuff together, making bombs.
Yeah.
Okay, so let's assume that I have now lithium here, and I want to bond that to chlorine. Then they need to form ions. So I find lithium, it's in group 1. So that ion is simply 1 plus or plus 1. That's going to be added to chlorine. And chlorine I found is in group 7. So chlorine will become -1. And now those two are really happy with one another because a positive and a negative charge bonds or attracts one another and the bonding takes place. And then I have lithium chloride. You see that?
Yeah.
So you've done this
Um, Slightly.
slightly.
It was, yeah. I did it very um recently.
Okay. So what they want you to do, we're going to look at Lewis and Cooper diagrams in the next lesson. So we're just busy with ions. So we're going to actually just touch on ionic bonding. So what they want you to do, they want you to write it in 3 steps. So the lithium atom loses an electron. So it becomes lithium 1 plus by giving an electron away. That's step 1. Step 2 is where the chlorine ion or atom rather gains the electron. Where does it get the electron? Well, it grabs the lithium's electron. So lithium and chlorine sees one another. Lithium
Yeah.
says, look, I have 1 electron in my outer shell. I really want to get rid of it. And chlorine says, look, I have 7 in my outer shell. I really need an electron. So just please give me the electron. So lithium just gives its electron away to chlorine.
Yeah.
It's like a deal or a trade. It's just like one is helping the other. And then chlorine becomes Cl1 minus. Now, I need to show you the following because they also want you to draw in their valence electrons. So lithium is in group 1. So there's 1 valence electron there. And chlorine is in group 7. And we're going to make crosses for the 7 electrons that it's got. You see that?
Yeah.
And then chlorine has its 7 electrons. And then we add that electron that we just received from lithium there. And the charge becomes -1. Now, if it's difficult to see, we just write it in a square bracket like that. So we don't get confused where the negatives and dots are. You can also make everything dots.
Yeah, that's what I did.
Yeah. Look, it's not a must that it must be crosses. I don't like those crosses either. So if I make all of these 7 dots, then I'm gonna I don't like the crosses. It's like silly. I know why they do it, because they want you to understand that these different electrons belong to chlorine and it's received a new electron from lithium. So I've got that. And then these two then really like one another because one is positive, one is negative. And then in the
Yeah.
third step, you're going to show how the positive lithium ion bonds with the negative chlorine ion to become lithium chloride. Okay. So these are called, this is ionic bonding, and this
Okay.
is called a Lewis diagram. It differs from covalent bonds, Lewis diagrams. Okay, tell me when you're ready.
Okay, I'm ready.
Okay, so now we're going to do a new one. Yeah. So I'm going to copy this. Go back with the periodic table. Right, we're going to do a new one. We are back with magnesium. And we're going to bond that with chlorine. And we just use chlorine. So let's use fluorine. Okay. So magnesium looks like this. It's in group
Yeah.
2. So if it's in group 2, it's got 2 valence electrons or 2 electrons in the outer shell. So what happens with it, it gives it away. It doesn't want it because it's got space for 6, another 6 or 8 in total. Doesn't want those. All metals will always give the electrons away. So it gives 2 electrons away and becomes 2 plus. Okay.
Okay.
And then fluorine is in group 7. So it's got 7 valence electrons. It's got space for 1. So it can actually only grab 1 and then become fluorine. There's, I'm just going to do the new electron in pink. They got a new electron there. So it becomes -1. And we do square brackets around it, just to show that all the electrons are surrounded. But now we have a problem. Magnesium gave 2 electrons away and fluorine only grabbed 1 electron. So this part of the equation needs to multiply with 2. In other words, I have to add another fluorine ion. Do you understand that?
Yeah.
Because there's 2 electrons available, so there's another fluorine ion. So what happens in stage 3 is the 1 magnesium 2 plus ion will bond with 2 fluorine ions because there's space for 2. And then that will give me, look at this, MgF2. Now, obviously, I've showed you the whole, all 3 steps of the Lewis diagrams. You must be able to do number 3, the end part, on your own in an equation. We can't always do all 3 steps.
Yeah.
Okay, so tell me when you're ready.
I'm ready.
Okay, so we're going to copy this. So I might just ask you the following. Write an equation, write a formula for now of, let's say potassium oxide. And I think it's 2 words. Potassium oxide.
So that would be potassium and oxygen,
Yes.
right?
Okay. So let's write potassium. Potassium is K and oxygen is O. So now I'm trying to find potassium. There we go. Potassium is in group 1, which simply means it's got a ion of +1. And
Yeah.
oxygen is in group 6. And oxygen has a charge of 2 minus.
Yeah.
Okay, so now look at this. I need 2 potassiums. I need another potassium to balance the charges because 2 positives goes with 2 negatives. Do you agree?
Yes.
So the end results will be K2O. See that? 2 Ks and 1 O.
Okay, that makes sense.
So some students are clever. They say, no, look, there's an easier way to do it. The value on the oxygen just goes there, and the charge on the potassium just goes there. So that becomes
Yes.
K2O1, but I don't write the 1.
Yeah.
These are all at the moment mono atomic bonds. So we only have one atom bonding with one atom. Later, we will have carbonate, sulfate, sulfites, lots of others. But this is just the basic, where you have one element bonding with another element. Okay, now you're going to try and do the following. I want you to write a formula for okay, there we go. Let's say calcium um, bromide.
So that would be the Ca
Ca and the bromine.
and yeah. I'm not sure where oh
Bromine
there.
is in group 7.
So
You'll
mine.
learn the group
Oh,
7 ones is fluorine, chlorine, bromine, iodine. And they are very
yeah.
important.
So then you would do. Could you do Br
Okay, just get charges first.
2
Calcium is in group 2
Oh yeah. 2 plus
and bromine.
and negative.
Okay, so the 2 is going to go with the bromine and the 1 with the calcium.
Yeah. Okay, that's how you do. Okay.
Okay,
Okay.
right. What about, let's do a difficult one. Aluminium oxide. Okay, I'll help you find those. Here's aluminium.
So it's
Alu
oxygen and element.
okay, we always write the metal first. So aluminium is first and oxygen is second.
Okay. And then since aluminium is in the third,
Yes.
it's a plus a 3 plus.
3 plus. And oxygen.
Oxygen is in 2 negative.
Okay, what does aluminium oxide look like?
Uh A L2O3.
Very good.
Okay.
Right, good. I'll throw in a couple of tests in the group.
Okay.
All right. That's it. Very good.
Thank you.
It's been really helpful that you've actually looked at the work prior,
Yeah.
because that's made it, we've done a ton of work now, actually. We've progressed a lot. So
Yeah.
I can't send you all the tests. I'll send you a couple of tests that's relevant to today's, but we're gonna be doing we're gonna be looking at polyatomic ions next week, and we also have to start looking at Lewis diagrams. Okay.
Okay.
All right. Okay, James. Well,
Thank you. Bye bye.
bye.